Hello, how to solve t power t equals t power 3, solving for all values of t. Now, if you have a power b and this equals a power c, since the bases are the same, you can say b equals c. Now, we can say that t equals 3. So, but we have some other solutions here that we are going to solve, and because of that, let's solve it the right way. T power t equals t raised to the power of 3. What I can do is to take the natural log of t raised to the power of t. This equals natural log of t raised to the power of 3. Now, if you have natural log of p raised to the power of q, this equals q times natural log of p. So this will give us t times natural log of t equals 3 times natural log of t. So let's multiply this out. We have t natural log of t equals 3 natural log of t. So what I can do would be to divide this by natural log of t and divide this by natural log of t. This eliminate this eliminate this. So from here I can have t equals 3. And this is the same solution that we had previously using this comparison method. Now, like I said earlier on, there is another value for t. So let's pick it up from here. Let's form an equation right here. I have t times ln t, this is t ln t equals 3 times ln t, this is 3 ln t. I can move this over here. This is t ln t minus 3 ln t equals 0. So what I can do again is to factor out the common term, in this case, ln t. So we have ln t times, if you factor out ln t from here, you have t left, minus factor out ln t here, you have 3, and this equals 0. So at this point, you can equate each of these to 0. Equate ln t to 0 and t minus 3 to 0. You have ln t equals 0. You have t minus 3 equals 0. So what do? I need to solve this individual equation. So I'm going to start with t minus 3 equals 0. Solving this, I simply move this over here of t equals 3. This is my first solution. Then to solve this other one here, I make use of e. I can have e power ln t equals e power 0. So what happens here is that the e eliminate the ln. I have t equals e power 0. And e to the power of 0 is 1, so I have t equals 1. T equals 1, t equals 3. Now we are getting two different solutions compared to the first method that we had only one solution. Now, let's solve this whole equation using a very different approach. T power t equals t power 3. What I can do would be to divide this by t power 3. Divide this by t power 3. This eliminate this. Half t power t equals t raised to the power of 3. And this equals 1. So, consider this identity. A power n divided by a power n equals a power n minus m. So what will happen here is I'm going to have t power t minus 3 equals 1. Because the base is here, the same, we can subtract the exponent. So we are going to have t minus 3, t power t minus 3 equals 1. I can make use of natural log. I can have natural log of t power t minus 3 equals natural log of 1. So at this particular point in time, if you have natural log of a power p, this equals p times natural log of a. So what this simply means is that the t minus 3 will come behind this. So we have t minus 3 times natural log of t equals natural log of 1. So from here, I have t minus 3 times natural log of t equals the natural log of 1 here is 0. I can replace it with 0. So from here, I have t minus 3 equals 0. I can also have natural log of t equals 0. So solving these individual equations, we start with this first equation here. I move negative 3 over here. I can have t equals 3. That's my t1. To solve this other one here, I can, in use of e, have e power ln t equals e power 0. This eliminates this. So what I'm going to have is t equals e power 0. And any number raised to the power of 0 is 1. So I have t equals 1. So have you seen that? Now we are getting the same two solutions back again using this method. So what we can do is to check. We have t equals 3 and t equals 1. And the question is t power t equals t power 3. Let's start by inserting 3. For t, I have 3 power 3 equals 3 power 3. This is 27 and this equals 27. Now let's also consider when t is 1. We have t power t equals t power 3. When t is 1, I have 1 power 1. Is it the same thing as 1 power 3? Now what you should know is that 1 raised to the power of n number is 1. And 1 raised to the power of 1 is 1. So going by that, 1 power 1 is 1. And 1 power 3 is 1. So we have the same value on both sides. So this shows that these two solutions are correct. This is how you can solve these exponential problems step by step. So that is it. Thank you and goodbye.